Hi grade 10s. This is the diagnostic quiz video for the pre-lesson activity on Saturday about physical and chemical change. I hope you like this new format with the diagnostic questions being separate from the actual pre-lesson tutorial. I think it's important to separate the diagnostic quiz from the actual pre-lesson activity tutorial. Firstly, to keep the videos as short as possible. And secondly, here in the diagnostic quiz video, I can also provide you with a brief outline of some of the important content that might help you understand where you went wrong in the questions. So this video can serve to help build your content knowledge too. Let's begin the diagnostic test. Remember, if the questions are going too quickly, you can pause the video. So here are the diagnostic questions for lesson 14, the physical and chemical change quiz. Remember, if you are part of the UP's PUA program, please log on and complete the diagnostic on ClickUp. Okay, grade 10s, let's check our understanding. Mark as the answers appear. Remember, if you got questions wrong, it's a good indication of what you still need to work on. You should have a pen or pencil to check your answers. Let's see how well you did on this quiz about physical and chemical change. So the answer for the first question is B. B is an example of a physical change because the glass breaking, it is still glass. C is an example of a chemical change because the plant uses sunlight as energy to make food. For number 3, the answer is B. A physical change can be reversed without too much energy being required. Although some chemical reactions are reversible, but it requires energy. For number 4, A, it's a chemical change. A chemical change always results in a new substance being formed. Number 5, the answer is B. If the chemical properties remain unchanged, it's the same chemical. So no new substance was formed. It's a physical change. For number 6, the answer is C. When water boils to form water vapor, it's still water. Water vapor can be condensed to form liquid water quite easily. The change is easily reversible. Iron and silver, shiny metals, which have luster, if they rust or become tarnished, they lose that luster. Paper being burnt, it becomes ash, so that's also a chemical change. 7, answer is B. The composition stays the same in a physical change. If the composition changes, it means a new substance is being formed, and that's a chemical change. In a phase change, which is a physical change, the substance changes form, e.g. from solid to liquid. So a form change is always equal to a physical change, and the mass will always be conserved. The answer for number 8 is C. Frozen water is still water. Cut wood is still wood. A bent wire is still wire. These are all physical changes. But that baked bread and that delicious smell is a chemical change. Number 9, the answer is B. A change in shape is a clue for a physical change. The rest are clues for chemical changes. For number 10, the answer is C. Mass is conserved in a physical change and a chemical change. The density can change. A liquid is less dense than a solid. A new chemical might have a different density. Shape can change. Wood and cut wood or chlorine gas and sodium forming sodium chloride. So let's have a look if something is a physical or a chemical change and how to tell the difference. We'll recap what we did last week and we'll look at some examples from the diagnostic quiz. Firstly, from the Siavula textbook, a physical change is defined as a change that can be seen or felt, but that does not involve the breakup of particles in the reaction. During a physical change, the form of matter may change, but not its identity. So water remains water. A chemical change occurs when one or more substances change into other materials. A chemical reaction involves the formation of new substances with different properties. That is key. The properties are different. So let's look at some examples. Chopping that piece of wood into two. Yes, that's a physical change. It's still wood. When a glass is shattered into smaller pieces, the form has changed, but the glass is still glass. It is still transparent. It still has the same properties. When you crush substances together to form a mixture, that mixture still contains the different things that were crushed. Their properties remain the same and they can easily be separated. When when ice melts to form water, it's still water. If you freeze it, that water will become ice. When you dissolve sugar in water, the sugar disappears, but if you drink the water, it will taste sugary. The sugar is still there in the water. And when steam forms and water vapor forms when water boils, if you condense the steam and the water vapor, it will form back into water quite easily. It's still water. It has not formed a new substance. Those are all examples of physical changes. So how do we know if something is a physical change? In a physical change, there may be a change in shape, but not in composition. There may be a change in form, e.g. from a solid to a liquid to a gas, but there's no change in composition. A physical change is reversible. Yes, it may take effort to put the glass back together and the two pieces of wood, but it can still be done. There may even be a change in density because a gas is less dense than a liquid and a liquid is less dense than a solid. But it's only because of the change of form. There's no change in composition. So in each of these cases, no new substance is formed. Therefore, these are all examples of physical changes. Now, let's look at phase change. There is a solid piece of ice. You heat it, it becomes liquid water. It changes shape from a fixed shape to the liquid which takes the shape of the glass. Heat it further, it will form steam, and a gas and water vapor will take up the space that you give it. And it will take up the shape of the container that it is in, just like water, but it will spread out. The region 2 and region 4 are where the phase change occurs, where energy goes into change to break apart the particles. As you can see in the next graph, the particles are arranged in a regular pattern. When you heat it, it becomes liquid, less order, and gas particles are far apart. So from solid to a liquid is melting, from a liquid to a solid is freezing. Condensation is when gas goes to a liquid, and boiling is when it goes from a liquid to a gas. So in a phase change, there may be a change in form, but not in composition. These physical changes are reversible as seen by those arrows. When you heat ice, it melts. You add heat to water, it boils, but you can condense water and you can freeze water back into ice. There may be a change in density again, but still it is water. The particles may even be rearranged, but no new substance forms. That is how we know it's a physical change. And the number of particles stays the same, so mass is conserved in a physical change. Let's look at some of the clues for a chemical change. Firstly, there could be a color change. For example, you bake dough into bread. It changes from that whitey color to brown, and there's that delicious smell. So there's an odor as well. That's the second clue. So the second clue could be a smell or an odor. For example, eggs rotting. That is a chemical change. That's bad smell is due to a chemical change. New matter may be made. For example, you burn wood. The wood changes to ash. Something new is formed during the process. And heat and light are given off. Bubbles may form. That's another clue. For example, baking soda added to vinegar creates carbon dioxide gas, but in a chemical change, you will see if bubbles form, then you know it's a chemical change. And finally, if heat or light are given off, or there is an explosion, such as with fireworks, the burning chemicals create heat and light, and often accompanied with a loud bang or boom. Those are all clues to something being a chemical change. So we know, for example, that when baking bread is a chemical change. There is a change in color, and there's also the odor and smell. What about toasting bread? Well, this is another example of a chemical change. You cannot undo the toast. And you see a color change, and there is a change in the odor or smell. Some examples of chemical changes. The hydrogen balloons exploding. There is the heat and light given off, and there is an explosion or a bang. So it's a chemical change. Iron rusting. Look at that shiny iron with its luster. It is now changed color to something that is red. That change in color indicates a chemical change. The same with silver. Shiny bright silver becomes dull and black. That is an example of a chemical change because there is a color change. When you burn wood, again, heat and light are given off, plus ash forms, that new substance forms. Therefore, it is a chemical change. Something new has been formed. So coming to a burning candle. A candle produces heat and light. The candle gets smaller and disappears. Therefore, burning a candle is an example of a chemical change. There is the example now of vinegar with baking soda. The bubbles are produced. If bubbles are produced, it is an example of a chemical change. Here are two substances. When you chuck them together, it changes color to this bright yellow, and it forms a powder, what we call a precipitate. If a precipitate forms, that is also an example of a chemical change. So if a solid forms when you add two liquids together, that's a chemical change, it's a precipitate. So any change in color generally indicates a chemical change. So that is the difference between a chemical and a physical change. The example was given of photosynthesis. Plants use sunlight as a source of energy. It takes in energy to change carbon dioxide and water into sugars and oxygen. So photosynthesis is an example of a chemical change that occurs in living organisms. So thanks for joining me. This is the Opinionated Science Educator.